Welcome to this analytic geometry problem. This is a quite simplistic but a little complicated problem. And first we have this big circle here inscribed in our square. The square is 16 meters on the side. So this means DC is 16 and BC is 16. So now the first question is to find the equation of this circle. This is the very simple problem. And the second one is a little more complicated. It asks us to find the equation of the small circle centered at L. That is quite little lengthy. And the third one is we have to find the area of this red part here, which is requires some analytic geometry. Okay. First, we can notice here that we have a line that is crossing O and going to D. This is a line with the equation y is equal to x. You can notice that among this line, wherever we are, the x is y because of the square. So that means 0 is 0, 0, and d is 8, 8. So that is already a good part of it. So we are going to start by finding the equation of the big circle here. Okay. So if we have a center of a circle with a center of x0 and y0, if this is the center, the general equation is x minus x0 squared plus y minus y0 squared is equal to r squared, r being the radius of the circle. On this one, we can see that from O to this tangency point here, we have 8. So this is half of the 16. So we can say that r is equal to 8 meters. All right, this is the radius of the circle. Now, we notice that it is centered at 0, 0 per our question. So that means x0 is 0 and y0 is 0. We can just say that x minus 0 squared plus y minus 0 squared is equal to 8 squared. Usually we can just calculate this one. We can find out that the final equation is x squared plus y squared is equal to 64. This is the equation of our circle. Okay? Yes, for the following question, I have just updated our figure here. We can see that this line here, we can find its equation. The equation of this line, I would say that that line equation is y is equal to x. Y is equal to x. So that is the equation of this line. Okay. Now we can see that these two circles have tangent. Tangent here. The points of tangency is f. So the equation of the small circle we are trying to find is x minus xl. I could say like this: x minus xl squared plus y minus yl squared is equal to fl squared. This is what we are going to try to find. All right, and we are going to work hard to try to find xl, yl, and fl. This is what is going to happen in the next few steps. All right. Alright, we have seen y is equal to, alright, we have seen y is equal to x, and x minus xl squared plus y minus yl squared is equal to r squared. This is this small circle with r, the small r is the radius fl here. First, let's find the coordinates of f at the point of tangency. So let's go for that. First, to find that, we have to see first what is the distance OF. Okay, we know that OF is equal to the circle radius is R. Okay, is equal to 8. All right. Now we know that y is equal to x is a tangent of 1. That means the angle theta at the center is equal to pi over 4. All right. So we can say that the cosine of that angle is equal to, we know, is the value of x, right? But we know it is equal to this small part here over the hypotenuse. All right, so we can say that cosine of pi over 4 is equal to xf, the value of xf here, xf over the hypotenuse is r is equal to 8. All right, that means that xf is equal to 8 cosine pi over 4 is equal to 8 square root of 2 over 2 is equal to 4 square root of 2. Being 45 degrees, we know that x is y, so we can say that point F has 4 coordinates. F is equal to 4 square root of 2 and 4 square root of 2. So that is one answer we have here. Okay. Our next step is to find the line K that is perpendicular to the line coming from the center, because of a point of tangent is perpendicular to the radius, of course, or any line contain that radius for this instance. So we know that if the first line is y is equal to x, the slope was m is equal to 1. Now the second line perpendicular to that one will have m prime is equal to negative 1, because the product of 2 has to be negative 1. So, and that line passes through point F, and we have the standard equation y minus y0 is equal to m factor the x minus factoring x minus x0. We are going to plug in xf. In this situation we have y minus yf is equal to m prime factoring x minus xf. All right, now it's easy. We just plug it in. We know that 1 minus 4 square root of 2 is equal to negative 1 factor x minus 4 square root of 2. All right, and we can have that y is equal to minus x plus 4 square root of 2 plus 4 square root of 2. All right, and finally y is equal to minus x plus 8 square root of 2. Okay, so we have the equation of the perpendicular line, and we know that that perpendicular is hitting the square at g and h. So we have to find g and h coordinates, and once we find that, we will know that that small circle here is inscribed in that triangle and the center is the incenter. So we are going to do that and find out first these 2 points before we proceed. Okay, please note that we can also express the line K in the following manner. We say x plus y is equal to 8 square root of 2. This is another valid notation for this line. Okay. Now let's try to find the coordinates of point G. We know that K passes through point G, and at that point we can see that Y is equal to 8. 8 is one of the dimensions of this square, and all where that horizontal line is Y is equal to 8. So line Y is equal to 8 intersects the line Y is equal to negative minus x plus 8 square root of 2. All we have to do is to equal them out, so we will get minus x plus 8 square root of 2 is equal to 8. We solve for that and we get x is equal to 8 square root of 2 minus 8. Okay. Otherwise it is also equal to 8 factor of square root of 2 minus 1, and at that time y is equal to 8. So we have point G. Okay. Now let's find the coordinates of point H. So point H, we have point H is also on that same line K, and the x of point H is equal to 8 because of this width of the square. So x is equal to 8. But we know that the equation of that line K is y is equal to negative x plus 8 square root of 2. We just replace plug in x, and so y of h is equal to minus 8 plus 8 square root of 2 is equal to 8 factorial square root of 2 minus 1. Okay, so the coordinates will be 8 square root or 8 times the quantity square root of minus 1, and then that will be for the y, and the x will be 8. Okay. Now the center of our inscribed circle L here is a point of concurrency of lines from the vertices, and that line split the vertices, bisects the vertices angles, and we know that D is like 90 degrees. That means the split angle here is 45 and 45, half of them, and these two angles are equal because we have seen it's the same distance. That means this one will be 95 over 2, this is 45, so pi is over 4, and this one is pi over 4, and this one also is pi over 4. So that will help us here because we have to find line M. Once we find line M, we find the intersection of M and the line Y is equal to X, and then we have the center of this small circle here. Okay, but what we have here is that line here also, since it bisects 45 degrees, so for line M, we have the tangent. But we can see this is pi over 8 here, the angle. So we can say theta is equal to pi over 8, and we can see also that it is going down, so the tangent will be negative. So actually the angle is, theta is negative pi over 8. So we have to calculate the tangent. We calculate tangent of theta is negative pi over 8. We know that tangent of negative theta is negative tangent theta. All right, so we have to find tangent of pi over 8, but we know that tangent of pi over 8 is, we know that pi over 8 is just half of pi over 4. So that means tangent pi over 8 is equal to 1 minus cosine pi over 4 over sine pi over 4. This is a formula we have. We know that tangent of theta is equal to 1 minus cosine of 2 theta over sine of 2 theta. Okay, this is just what I'm going to use here. But we know cosine pi over 4, we can say here is equal to 1 minus square root 2 over 2 over square root 2 over 2. This means that this one will become 2 minus square root of 2 over square root of 2, but we don't want to have the square root in the denominator. We can multiply both by square root of 2, so square root of 2 times 2 minus square root of 2 over 2. That will bring it to 2 square root of 2 minus square root of 2 times square root of 2 is 2 over 2. This is equal to factoring square root of 2 minus 1 over 2. Otherwise, tangent pi over 8 is equal to square root of 2 minus 1, bringing home that tangent negative minus pi over 8 is equal to minus all that, minus square root of 2 minus 1. Okay? Now we can use the general rule y minus yg. Y minus yg, this line passes through g also, is equal to m, the slope, factoring the x minus xg. But here we know already the coordinates of point G, we noted it here, so we can just plug it in and we can find the equation of a line M. Okay? So we can say that y minus 8 is equal to minus square root of 2 minus 1 times x minus the coordinate xg. That means 8 square root of 2 minus 1. This is what we are getting. Okay? When we continue, we can say that y is equal to negative of all this minus 1 factor x minus 8 square root of 2 minus 1 plus 8. Okay, so we multiply this. Okay, we get y is equal to negative square root of 2 minus 1 times x. We keep it as is, and then plus square root of 2 minus 1 times square root 2 of minus 1 is equal to 8 times square root of 2 minus 1 squared, then plus 8. Okay, we can say that y is equal to minus square root of 2 minus 1 x plus 8 factoring 2 minus 2 square root of 2 plus 1 plus 8. Okay, now we can introduce that 8 here. 1 is equal to minus square root of 2 minus 1 x plus 8 factor the 2 minus 2 square root of 2 plus 1 plus 1. Okay, so we can say y is equal to minus square root of 2 minus 1 times x plus, now we can see we have 2 plus 2, 4. We can pull out 2 and pull out 2 here. That is 16 times 2 minus square root of 2. Alright? So this is the equation of our line M. Okay? Now y is equal to x and line M meet at the point L. So we can make them meet there. So we can say y is equal to x. So that means x is equal to all this. This is missing the x here actually. So it is minus square root of 2 minus 1 x plus 16 times 2 minus square root of 2. So we solve for this one. We can say that x factor of 1 plus square root of 2 minus 1 is equal to 16 times 2 minus square root of 2. Otherwise, square root of 2x is equal to 16 times 2 minus square root of 2. Dividing both sides by square root of 2 gives x is equal to 16. Or what we can do also, we can multiply. Let's multiply both sides by square root of 2. That means 2x is equal to 16 times 2 square root of 2 minus 2. Okay? And that means x is equal to 8 times 2 square root of 2 minus 2. You can pull out the 2. X is equal to 16 times square root of 2 minus 1. Okay? But remember, y is equal to x, so y also will be at that point at a. So xl is equal to that. That means yl is also the same thing, 16 square root of 2 minus 1. Okay? Now we have point L, and earlier we calculated point F. We found F was 4 square root of 2 and 4 square root of 2, where the line K was passing. Now we have that information, and all we need here now, we have FL to calculate. That is small r is equal to FL is equal to square root. This one calculation simply is equal to 16 square root, let's see, 16 square root of 2 minus 16 plus, no, minus 4 square root of 2 squared times 2 here is equal to square root of 2 times 12 square root of 2. Let's see, 12 square root of 2 minus 16. All right. That will make it here 24 minus 16 square root of 2. So that will be R. R is equal to 24 minus 16 square root of 2. This is also, if you want numbers, it will be 1.373. This is the radius FL here, right? Okay. Finally, we can see that the equation of circle L is equal to x minus 16 times the quantity square root 2 minus 1 all squared plus y minus quantity minus 16 times quantity square root of 2 minus 1 all squared is equal to quantity 24 minus 16 square root of 2 all squared. So this is the equation of our circle. Now let's go back to try to find that small area here, but we know already that we have the intercepted arc ji, and we can see clearly that ji, the arc is like just 90 degrees, and we can find the circle segment here, and once we have the circle segment, we can reduce it from the total area of this triangle DJI. Okay, so quickly we find the coordinates of J and I, and then we are done. Okay. Or instead, I'm going to calculate this distance Ji instead of calculating the coordinates. And once I have that, and I have already this here, and I can calculate Ln, coordinate of point n here. Once I have Ln, I can calculate the rest. So first, let's calculate Ji. We know that this is a radius, this is a radius. So Ji is simply the sum of the squares of the radius, okay? So we can say that Ji squared is equal to R squared. That means that Ji squared is equal to 2 times 1.373 squared is equal to 2 times 1.884. Okay, and let's see. Or simply we can say that Ji, we can say here is equal to R square root of 2 is equal to 1.373 times square root of 2. That gives us simply here Ji, let's calculate, is equal 1.941. So Ji is 1.941. Okay, so we have that one. So for Ln, we know if we have the radius here, we have half of Ji here, we can find Ln. So Ln is equal to square root of radius squared, 1.373 squared, minus half of Ji, 1.941 over 2 squared. All right. Yes, we know that this one will be 0.970 squared here, 0.971 actually. Okay. Okay. Let's see. Let's bring our Texas instrument. We have square root of 1.373 squared minus 0.971 squared. Let's find out what it is. Okay, 0.970. We can take 0.970. Alright, that's fine. Now we have the segment here to calculate. All right. So the area of the segment is half of r squared times alpha minus sine alpha. Alpha in radian. Our alpha is pi over 2, and pi over 2, you know, sine alpha in that situation, sine pi over 2 is equal to 1. So we just plug them in. We have r squared also, we have r. So area of segment is equal to 1/2 of 1.373 squared times pi over 2 minus sine pi over 2. Alright, that gives us, after calculation with our Texas instrument, it gives us 0.538. Okay, thank you. Now all is left here is the area of this DJI, but we need dn, calculating dn quickly, and it should be a fast affair, you know, calculating dn. But we know that OD is all the lengths, and we can have that dn is equal to OD minus all the length minus OF, which is the radius big A, and minus FL, we know FL, we already, minus LN, we just calculated LN. Alright, so that means that dn is equal to OD, which is 8 square root of 2, alright, minus OF, which is 8, minus RFL, which is 1.373 or 24 minus 16 square root of 2, alright, minus ln minus 0.970, alright. Let's bring our Texas instrument for that. Alright, we have our data here now. Let's hit enter on that. Alright, so we got 0.971 as the height of our triangle here. This is dn. Now all we have to calculate is the area of that triangle, which is half of that height times ji, and then subtract that segment circle of 0.538. Okay? Now that we have ji is 1.941 and dn is 0.971, that means area, let's see here, area of DJI is equal to half of the product of 0.971 times 1.941, alright, is equal to 0.942 square meters. Now the distance, shaded area, red area, is equal to 0.942 minus 0.538 is equal to 0.404 square meters. That is what we are looking for. Okay. So finally, let's make it in another color here. Which color? Okay, let's take the white. That's fine. So finally, we have area of shaded part 0.404 square meters. Okay, thank you very much. It was very long, but this is covering much of analytic geometry, and feel free to pause it and see what we did, and you can always shoot me a message, and I will be free to answer. Okay, thank you.